Okay, so we are starting Unit 2 today, so we're looking at Day 1, which is power functions. So to start out with, we're going to figure out what is a power function. So a power function is going to be any function that can be written in the form f of x equals ax to the b power. So in this case, a cannot be equal to 0, and x cannot be equal to 0. Okay, if those are equal to 0, then it's going to cancel this whole thing out. So ax to the b power. Okay, x is your variable here, where a and b are just going to be constants. A is going to be called your constant of variation here, or your proportion. So whenever the power on x is positive, so if it's x to some positive power, then that means we are having a direct variation. When the power on x is negative, so if this was like x to the negative third power, then that's when we have an inverse variation. And we'll talk more about what that's going to mean in word problems a little bit later. So some examples from some formulas that you've seen before. So circumference formula is 2 pi r. So this is a power function. It's 2 pi, r would just be to the first power. So r is your variable here, and it's to the first power, so this is a power of 1. Whereas that constant of variation is just the 2 pi out front. Another formula that you've seen before is area of a circle. So pi r squared. So our power here is 2 on my r, with that constant of variation just being pi. Force of gravity, the formula is F equals k divided by d squared. So another way to write that, instead of having a division, you could do k times d to the negative 2. That would bring it to the top, which would make this now be a power function. So that power there is negative 2 on the d, but the k would be your constant of variation. And then Boyle's law is V equals k divided by p. So we could rewrite that as a power function by moving the p to the numerator and make that k times p to the negative 1. So my power would be negative 1, and then my constant of variation would be that k. So a few other examples that aren't on here that I want to show you. So if we just had f of x equals 1 over x. To make that into a power function, we could rewrite that as just x to the negative 1. So that means my power on that is that negative 1. Alright, another example, if we had f of x equals the square root of x. To rewrite that as a power function, that is x to the 1/2 power. The way you get that is just x to the first power in here, and then because it's a square root, there's a 2 out there, so x is x to the 1/2 power. So that power there would be 1/2. Okay, another example, we had f of x equals the cube root of x to the 4th. To write that as a power function, that would be x to the 4th over 3, so 4/3. So that power would be 4/3. So a power function just has to be in the form ax to the b power, okay? Your variable just has to have some power that it's to, and I didn't write the constant of variation for these 3, but these would all just have a constant of variation of 1 because there's nothing out front. Okay, so what we're going to be doing first is we're going to be writing a power function given ordered pairs. Okay, so they tell us a power function passes through the point 1.5 and 313.5. We want to write an equation for this power function. Well, we know a power function is the formula y equals ax to the b power. So our goal is to figure out what is a and what is b. So what you're going to do, since these are ordered pairs, this is an x value, that's a y value, and this is an x value, and that's a y value. So we're going to set up a system of equations to solve this. So what you want to do is you want to pick the one that has we're going to need to divide these things, so we need to pick the bigger y value first. So I'm going to do this point first. And I'm just going to plug this into y equals ax to the b. So the y value here is 13.5 equals, I don't know what a is. The x value here is 3. And I don't know what b is. Okay, now I'm going to plug in this next point. I'm going to write it directly underneath here. So the y value is 0.5. We don't know the a value. The x value is 1. And the b value we don't know. So we're going to take these two equations that we made here, and we have a system of equations. We're going to divide. And the reason we're going to divide is because if we divide these two things, these a's will cancel here. Okay? So 13.5 divided by 0.5 will give us 27. Then we already canceled out the a's. Here you can divide 3 divided by 1, which is 3. The b is stuck onto the 3 and the 1, so the b will just stay. Okay, so you can do this a couple of different ways. If you just know 3 to what power gives you 27, that's fine. Or if you want to make them have the same base. So if I rewrite 27 to have a base of 3, 3 to the third power gives me 27. Now that these have the same bases, that means b has to be equal to 3. So if you know just 3 to the third power is 27, you can just figure out b is 3. We'll figure out how to do that more with logs and exponentials later in the year. Okay, so now I know my equation is not just y equals ax to the b, I know b is 3. So y equals ax to the third power. So all we have left to figure out is what a is. So to get a, you're just going to plug in either one of these equations. The one that has the 1 will probably be easier, so I'm going to use that one. So the y value here is 0.5. We don't know a. X here is 1. And then we know that's to the third power. Well, 1 to the third power is just 1. So that means a is just going to be 0.5. So my power function here is going to be y equals a, which is 0.5, x to the b, which is 3. So y equals 0.5, x to the third power is that power function. Okay, so we're going to try another one of these. Pretty much the same kind of thing. Just different order pairs. So this one says a power function contains the points 1, -3 and -2, -48. And we want to write an equation. So we know a power function is y equals ax to the b power. We've got to fill in what a and b are going to be. So we have two ordered pairs. And remember, we're going to be dividing. So even though this is a negative number, this 48 will be easier to do 48 divided by number. So I'm going to do this one first. The y value here is -48. We don't know a. The x value here is -2. We don't know b. Then I'm going to plug in the other point. So the y value here is -3. We don't know a. The x value is 1. And we don't know b. So remember, we're going to divide these. The reason we're dividing is so that a will cancel. Well, -48 divided by -3 is going to be 16. The a's canceled, and then -2 divided by 1 will be -2. And then the b has to stay. So you're just figuring out, okay, -2 to what power gives me 16? Well, -2 to the fourth power gives you 16. So if that's how you want to figure out your b, that's perfectly fine. Okay, so now we know it's not just y equals ax to the b, it's y equals ax to the fourth power. So we just have to figure out a, so you're going to plug in either one of these points. I usually pick the one that has 1. So if I plug this point into my equation, we'll have y is -3 equals, we don't know a, x is 1, and it's to the fourth power. Well, 1 to the fourth power is just 1, so that means a has to be -3. So now my power function is just y equals a is -3, x to the fourth power. And that's how you write a power function given your two coordinates there. Okay, next thing we're going to do, we're going to actually use the calculator for. So if you want to pull up your calculator in your Chromebook or get out your calculator. So we want to write a power function. So when we finish, remember our power function is y equals ax to the b power. That models this data in the table. So in your calculator, what you're going to do, I'm going to write down the steps, but you're going to click on Stat, and you're going to click on Edit first. So you're going to click on Stat, and you're going to click Edit. Clear all this stuff. And then in your list 1 is where you're going to type everything that's in the X. So my list 1, I'm going to type the 1. So 1, enter, 4, 9, 16, 25. And then in your list 2 is where you're going to type everything in the Y here. So you'll type in 2, 4, 6, 8, 10. So your L1 and L2, you did that. Okay, after that you're going to hit Stat. And then you're going to go over to Calc. And the one that you're going to pick is letter A, which says Power Regression. Go down to A, Power Regression. Okay, make sure it says L1, L2. And then everything else, you can just go the frequent list and store. You don't need anything there. And you're going to hit Calculate. And now it should say on your calculator, y equals ax to the b. That is the formula. It tells you a is 2 and b is 0.5. Okay? So that formula is fine, but if this was multiple choice, this answer will probably not be there. So I want you to think about other ways we could write this answer. So 0.5 is the same thing as 1/2. So that would be another answer, 2x to the 1/2. Or if you have an fractional exponent, you can rewrite that as a square root or root. So this is the same thing as saying 2. This is just x to the first power. It would just be an x underneath. And because it's 2 here, it would just be a square or square root, so you don't really have to write the 2. So the way this would probably be written on a multiple choice would be y equals 2 square root of x. So just make sure you know all these are the same thing, okay? This is a power function, but it could be rewritten like this.